Okay, in a previous video we went through a process of setting up a data file for your calculator. If you haven't done that, please do so before you continue with this video. It'll be more helpful if you can follow along with your data file. And if you're not sure about it, again, go to that video that's how to set up a data file using the TI-89 and the Voyage calculators, and do that before you continue here. And so we're going to assume that you've got your data file set up and it's named XYZ. That's the name I'll be showing you in this demonstration. So on your two calculators, what we're going to do is we're going to do some data analysis using either the TI-89 or the Voyage calculator. The functionality on the calculators is the same. It's just clearly that the interface and the keyboard structure is different on them, but they work the same way. So our steps to doing data analysis, the first thing we have to do is we have to input the data. And we previously set up a data file, so we're ready to input the data. The calculator's ready to go. Second thing is we need to look at a graph of the data. It's useful to get a visual perspective of the numeric information, and graphs can help us do that, so we'll go through that process. And finally, then we will use an appropriate calculator process for analyzing the data. So our first step in inputting the data, you want to turn your calculator on. So I've turned my calculator on and I've got my apps desktop turned off. So I come to this screen. You'll probably have different information there than I do, but this is the screen. I'll use the menu setting, and I'm going to press the apps button. I get a drop down menu. I'm going to go to the data matrix editor and select open. That's because I have set up a data file in my calculator. I want to open that data file and then be able to input my numeric information. So when you select open, you'll have your data option in the main menu, and if you'll notice, I have two files set up, one that's called Bob and one that's called XYZ. In this video we'll be using the XYZ file. So that should be already set up. If you've done that, then we'll continue, and you press enter to continue to the data screen. So when you press enter on a file, you will either have number values in the columns or not. This was a new data file, so there are no values in here. This screen is similar to a spreadsheet with rows and columns. Columns are labeled with C1, C2, C3, and so forth, and the rows are numbered 1 through 7 as far as what we can see on the screen. The data set we're going to use for this demonstration is, as you see here, I have a column of X values and a column of Y values, and we're going to input our data so that the X values fall in column 1 and the Y values fall in column 2. So moving the cursor through the various cells, we input the numbers, and it's critical to make sure that the data you enter matches exactly with the problem you're working on. If you've done everything correctly, then your data will match, your results will match, and everything will be good. If you made one entry error and one wrong number input, you might do all the correct processes, but your results will be in error because of a data entry error. So be very careful as you input data and double check that you've got a match between the data set and what the calculator has. So the first thing we're going to do in this example is we're going to look at a scatter plot of this data where we're going to use our X and Y and create points on a graph. The calculator will do that. It'll automate it, but we have to first set up the plot structure so the calculator will know what to do. And so we're going to select option F2, plot setup. And so in that option, we're going to set up plot number 1 to be a scatter plot of the data, and we're going to select F1 to define the information about that scatter plot. So when you select F1, we get a menu of how to, the type of information or type of plot or the options we can use to set this up. And we want the plot type to be a scatter plot. If you right arrow, there are other options you could use. In this case, we're going to use a scatter plot, which is just points on the graph. Each of those points will be marked with a box. The calculator is going to get the X values from column 1 or C1, that's where we put the X values from our data, and the Y values from column 2, and then we're going to leave this frequencies and categories set to no. Later in other statistical processes, this option may be changed to yes, but for now we'll leave that set to no. So now we're going to go to our Y equals screen, do a little cleanup in case we need to, and we want to make sure that all of the functions that you see, Y1 through whatever, that there are no formulas there. You'll notice by plot 1 we have a check mark that indicates that the plot 1 will graph. We've got a summary of how it's set up with the scatter plot marking with a box. X's are in column 1 and Y's are in column 2. And so now we're ready to view the scatter plot. So from here we're going to press F2 zoom. That gives us the various options for window sizing our graph, and we're going to select option number 9. Option 9, zoom data. The calculator will automatically size the window for the numbers that we have input, and it saves a bunch of time of trying to set a window that's functional. So calculator automatically adjusts the window, and then we see the scatter plot. Each of these points, each of these boxes correspond to one of the data points, the X and the Y, from the information that we just input. And so our next process we'll look at is using the calculator to analyze the data. Okay, we are ready to analyze our data. We have our data set. We have that data set input to the calculator. And the process of regression is a statistical process of creating or generating a best fit function that matches our given data set. For this example, we're going to use linear regression to create a best fit line for the data. Other processes are similar in our calculator, the difference being when we make that choice of the type of regression, we could choose something else if we wanted to do a different type of regression. Linear regression is the most common process that's used in statistical analysis, so that's what we're going to do for this example. So we have our data in place. Choice F5 from our data input screen is where we make our selection for calculations. So if we select that F5, brings us to our main screen to do calculations, and as you see the default here has 2 variables. So what we're going to do is we're going to right arrow to get our other options available. When we right arrow, we get all of these various options of processes, the regressions or the REGs, and we're looking for choice number 5, which is our linear regression. That's the choice we're making for this particular analysis. So when we select that linear regression, we press enter. We'll input the X values. We indicate that the calculator should find those values in C1. That's where we put them into our list. The Y values are in C2. And it's important, we're going to store that regression equation in the calculator as y1 of x. Now you could right arrow and choose other options for storing the equation, but for now we'll just store that in y1 of x. We need to store the equation if we're going to do any predicting with that equation. So we're going to press enter to go ahead and have the calculator process that for us. Calculator returns a little pop-up window that gives us the form of the equation y equal ax plus b with the various values for a and b. We have these correlations and r squareds, and that r squared we can interpret it, the correlation number, if we square it we get r squared, but this gives us kind of an indicator of accuracy of fit, and in this case the line generated fits the data to about 95% accuracy. So the final part of the process of regression is where we're going to actually use that equation to predict values that are not shown in our data table. We stored that equation in y1. So when we go to our y equals screen for graphing, you notice my plot 1 is still turned on from the previous work, but the equation y1 has been transferred from the regression process into the graphing screen. And if we go to a zoom data window, then we get the window sized appropriately, and we now have our scatter plot along with the best fit line. And just observe that the best fit line goes through the data. It actually doesn't hit any of the points, but that gives us about that 95% accuracy of fit that we found through our process. So let's suppose we want to predict for values of x 4.5 or 6.6. 4.5 is not in the chart, nor is 6.6. We put that equation in the calculator and stored it as y1, and there's a very simple process that we can use to predict these values. So we go to our main calculating screen and simply input y1 parenthesis 4.5 and press enter, and when we do we get the predicted value of 18.5 for the y1 using a 4.5, and then for the other value we input the y1 of 6.6 and get a predicted value of 29. So we were able to use that regression equation to predict outside of the data values that are not given in the table. Well, that concludes the instruction about data analysis using the TI-89 and Voyage calculators. It'll help you if you practice these processes with some examples so that you can build your skills. You want to get to the point where you don't have to refer to the video or notes, and you're just going to know what to do. The processors are somewhat involved, but once you've done them a few times, it'll fall into place and make some sense. So till next time, have a good one, and we'll have some more for you later.